Hello and good day, doctor. My name is Amizhdhan BALAKRISHNAN and my matrix number is 231363008, and in this short video I'll be presenting my MATLAB code which demonstrates discrete time convolution of two signals using conv function. So this is my lab 2. I'll be presenting about convolutions. So this is the question that I'm gonna be presenting about today. So this is my exercise 2. So you can see this is the question given. Evaluate the convolution for y and equals to x. So this is what I will be presenting. So as you can see, I will show it in my MATLAB directly. So you can see this is the code. So first of all, I will step 1, I will define the input signal xn. So to start, I define a time vector n from 0 to 9. Though it's not directly used in plotting here, then I define the signal x bracket n as bracket 1 comma -2 1. Then I define the signal xn as, which is the short finite sequence. The vector n1 is used to set correct x-axis for plotting. So I'm defining this. So next is plot xn. In the first figure, as you can see here, I split the window into two subplots. On the left side, I plot the input signal xn using a blue stem plot with a thicker line for better visibility, which is this one, this whole thing here. Okay. For my step 3, I define the plot, the impulse response hn, which one. Now I define another signal hn as 10101 -1 that resembles a delayed impulse minus another impulse, something you see in filter design. I plot hn, as you can see here, something you see in filter design. I plot hn in red on the right side of the first figure. As you can see here, this one. Okay. So for my step 4, I perform the convolution. See here, this is the one. So for this, next I perform a convolution of xn and hn using MATLAB's built-in conv function. The result is stored in y, and I define entry to match the length of the convolution. Step 5, I plotted the output signal, which is for this one, this whole thing. Finally, I plot the output of the convolution yn in the second figure using a black stem plot. This result represents the output of a system with impulse response hn, which when give input xn. So you can see if I run the code, this is the output that I will be getting, this and this. So there are a total of 2 figures. So for the second question, which is this one, 2.3, I will start with I'll show it here also. So you can see for this part, this whole part, we begin by defining our time vector n from 0 to 19. This is useful for generating our exponential sequence later. Then we set the decay factor a to 0.9. The input signal xn is defined as 1 0 0 0 0 -1. This is likely a delayed negative impulse following a positive one, often used to test system behavior. And n1 is created to help plot the signal correctly, which is this one. Okay. So for the next one, plot signal input plot the input signal xn. So this one. For this part, we open a new figure window and use subplot 1 to 1 to split the figure. On the left, we plot xn using a blue stem plot to represent the discrete signal clearly. And for the defined for this part, Next, we define the impulse response Hn as a raised to the power of negative n, which means the values grow exponentially since a is less than 1. This creates an increased exponential sequence. We plot the signals in black on the right side. And for this part, we perform the convolution of xn and hn using the conv function in MATLAB. The output y is the result of passing the input through the system with impulse response hn, and 3 is defined to properly match the length of the output. And for this part, in a new figure window, we plot the output signal y in red. This input sequence xn based on the exponential behavior of hn. So I will now run the code. So as you can see, this is the output that we will be getting for this code for figure 1 and figure 2. This MATLAB code shows how convolution works between a finite input and an exponentially increased sequence. The output provides insights into how a system reacts when it delayed impulse signals. And also, for this code, this illustrate the fundamental operation of convolution between two discrete signals. We visualize the input signals x and the impulses response hn and the resulting output yn of the convolution. This process is critical in signal processing, especially for understanding in how systems respond to inputs. Thank you for watching my video. Thank you.